All right, guys. So I thought I'd give you a little bit more Fusion 360 goodness. The other day I designed, or just knocked up a couple of roller wheels for a VL81 Hoover, which I found abandoned on the side of a footpath. Somebody had left it out for the council, I guess. They just cut the lead off and taken the attachments and left it for dead. So I took it to bits. It's a good Hoover, nothing wrong with it. You just need a new motor. The motor, the tang inside the motor had snapped off due to condensation and corrosion. So why am I doing this video? Well, one of the front wheels, there's a sort of roller wheel at the front, two obviously at the back, two at the front, small ones, had fallen off, got lost, whatever. So I thought, well, just print one out then and create an axle out of a bit of brass tube that I had lying around. So I did, and it works. It works a treat. So how would you create it? But this time we're going to do it slightly differently. We're going to create a roller wheel, which is really just a kind of barrel, but we're going to do it using a loft. So I'll show you how to do it. It's pretty straightforward. First thing we need to do is obviously create a sketch. So we'll come down here, create, and create a sketch. You need to select a plane. So this is basically the plane XYZ as pointing to up here. This is your XYZ plane. So currently we're in this kind of ZX, Y coming out the back. And we're going to choose this bottom plane, right? That puts it nice and flat. So we're looking down from the top. All right, you can rotate these around, set your home, just puts it back in sort of looking from the Z axis, I suppose, from the left hand side. It's good for three-dimensional when you're doing your extrusion. So this is the middle where we want to actually start drawing. And don't forget these controls down the bottom are quite handy if you want to move stuff around, do orbits like free orbits, constrained orbit, zoom in, zoom out, display settings, grid and snaps and viewpoints. Over on the left hand side you have the kind of browser, your document settings, your name views, your origin, and your sketches. All right. And these are very handy. You just play around with these to get an idea. Origins and your sketches are quite useful because sometimes you can switch on and switch off or view and not view certain elements of the drawing. So you can look into it if you like. Although there's transparency in the drawings anyway, so you can actually see through, which is quite handy. Across the top you have this kind of ribbon. You got the design, render, animation, manufacture and drawing. And on the top left hand side you've got the ability to save and export into different formats, even 3D print. You can also capture an image, you can share stuff, launch a screencast, various view options, and you can create multiple tabs across the top. You can also get to your extensions. You can also look at your job status and your profile, and you've got some help. Across the top here is pretty straightforward what these mean. If you want to start with a drawing, you can insert a canvas. I think I pointed this out in one of my other videos, right? Or you can insert a derive or a decal, or insert a mesh or a drawing or a DXF, different formats. But what you're doing in allowing you to insert is you can actually have a picture in the background and then draw around it. I kind of like that idea, but on the other hand, I also like to sort of visualize what it is I want to do first of all. So fortunately, I'm quite I think most men have this, some women have it too, where you can just think three-dimensionally and you can visualize what it is you want to do, what you see in your mind's eye. Just look at an object, then translate that into a three-dimensional object, and then think about how you're going to draw that in a two-dimensional object and turning it into a three-dimensional object, which is what Fusion 360 is all about, really. Plus all these other features of working in different surfaces and metals and tools and plastics, and obviously combining drawings. And I'm only just learning this platform, but the more I get into it, the more, yeah, it's pretty cool. I knocked this wheel up originally, the Mark 1, in about 5 minutes and had it printed out in 10 minutes. Then I realized it wasn't good enough, so I did Mark 2, and then did different derivatives of it. But this is how I did the final version. So, what do you want to create? You can either use these favorites across the top, or you can just choose from any of these what you want to go and create, right? So we want to go and create a circle. Why? Because it's going to form the basis of our barrel. So we're going to create a barrel, a bit like a beer barrel. So it's going to have an elliptical outer edge like normal beer barrels do, uh, but it's going to be formed from the basis of a circle. So you select in the middle and just click once, and then let go of the left mouse and drag it away. The width of the barrel at the bottom, because I measured it on the existing one, is 10 millimeters. So just type in 10. If you want it 10 point something, put a decimal place, but otherwise 10, you've got the basis of your barrel. Now you can either use zoom or you can use your mouse wheel to zoom in, and you can use your hand to move around. But you can just hit escape, come out of that, because we're in hand mode or select mode, and you can see, yeah, we're 10 across there, right? You see the diameter across there. So that's the basis of our barrel. But now we need to think about making a vertical stack. And to do that, we need to do something called, under the solid tab, construct a offset plane. And the offset plane is then used to render up to the midpoint, which is going to be slightly wider because it's a barrel, remember, so the base will be 10 millimeter. But we're going to create another plane, and the plane above this plane, so now we're thinking more three-directional. So the plane above this one, we want it to be midpoint into the barrel. So if the barrel is a total of, say, 18.5 millimeters tall, the midpoint is going to be what? 9.25 millimeters tall. So we have that barrel there. Click on the home, and we can see this plane is directly above it. Click top, and it's back upon it. Now then, I just want to make sure that this plane is in it. We'll see if it's in the right place in a minute. So we now need to go back to create an additional, make sure that plane is there. I'll click home. Okay, let's go top. Let's zoom back out again. Let's move this into the middle. Let's go and let's go back and construct an offset plane again. Just make sure this is in the right place. I always like to make sure it's the bottom plane that I want. Yes, that's more like it. And it's going to be, you can also drag this up, look. See, that's better. It's a bit more graphical when you do things like this. You can see it's directly above this plane, but it is going to be 9.25 millimeters directly above this plane. Right. Zoom out. It's a bit fussy initially with Fusion 360, but you kind of get into it. So we have a plane directly above this plane, 9.25, which is the midpoint of 18.5 millimeters, right? So where we want to put another circle. So we're going to create another circle. So we're going to code sketch. Right, okay, and now we want to create a circle in the middle, but this one is going to be 12 millimeters across, and just hit the home button rather, and we can see whoopie-doo, it's in the middle and it's 12 millimeters across the top. So 10 millimeter circle here, 12 millimeter here. So we need a final plane. So let's click. Let's come back to solid. You have to be careful how you do this. Construct another offset plane. Again, clicking the bottom on this axis. So you just hover your mouse to the right here. It kind of turns an opaque-ish color. Not that one, but this one. right? And this one is going to be another, I think this is right, let's check it, 9.25. It's either 9.25 or 18.5 above. This is where it gets a bit tricky. I think it's going to be 18.5 above the bottom plane. See if I'm right. I think that's better. You've got to be careful because sometimes you can click on this plane, and if you do click on that plane, then you need to be 8.25 above that, because then that'll make 9.25 right above the middle plane, because then that would be 18.5 in total, right? This is why I was messing around with yesterday. I was having trouble with it, but I just had an epiphany. I thought, hang on a minute, there's multiple planes, but you've got to get your planes in the right place. So we say OK. Now let's click the home again. I'm not sure that plane's in the right place, but we'll see. We'll soon see. So I'm going to select it, and I'm going to create another sketch. It looks like it might be OK. Select the middle, one click, pull it away, 10. Cross fingers. Home. Yeah. So we got 3 planes. One on the bottom, one in the midpoint, one on the top. Right. So what we're going to do now? We're going to create a loft. A loft is a bit like its name implies. It's a cross section through all these 3 planes. Now, it doesn't have to be through these. It could just be between these 2 or these 2. You need to select the planes, right? So we'll select 1, hold the control key 2, hold control key 3, 3 circles selected, which is effectively on 3 separate planes, if that makes sense. And then we need to go and I think it's solid, create loft. And as you see, it creates a transitional shape between 2 or more sketch profiles or planar faces. Select a series of profiles or planar faces to define a shape. Optionally, select the rails or a centerpiece to guide the shape. Okay, so we select loft. There you go. So you now have effectively Fusion 360. This is a clever bit about Fusion 360. Like all good CAD programs, it's now looked at these 3 dimensions in a way, 3 separate planes. They're connected, and it's creating a new body out of these 3 planes. So we now have our elliptical edge, which is that barrel. Ooh. So then we say OK. So that's done. So we have our roller wheel effectively, and it's 10 millimeters across here, 10 millimeters across there, 12 millimeters across the middle, and it's a total of 18.5 because 9.25 up to the middle, 9.25 up to there, about 18.5. Now I could have made it 20, but 18.5 seems to be about the right size given the existing one. Now, in the middle of this barrel is going to be printed in TPU, which is a slightly rubbery or softer material, which is really funky for all sorts of things like phone covers and rubber bands. And they're not quite rubbery, but they're not bad actually. I printed rubber bands too. So TPU is much more elastic, whereas PLA is more rigid. But in the middle, we need a hub, right? So we need a hole in here. Now, there's 2 ways you can generate a hole. I can either just go and put a hole in the middle, so I can press H, yeah, let's see, and go and create myself a hole, all right? But what we're going to do instead is use a nice facility called Modify and select Shell, because we're looking at the shell and how far do you want to go in? Well, just drag it in, right? So if it's 10 millimeters on the outside, which we know, and I've pulled it in 1 millimeter, that's 9, isn't it? If I pull it in 2, that's 2 from 10, which is 8. If I pull it in again, then we get effectively 3 from the edge. So 3 from 10 leaves it at 7. If I set this at, let's think, 4 from the edge, 4 millimeters from the edge, it ends up being there. So you can sort of mess around with this to generate a hole if you want, right? I'm just going to do some checks here. I'm going to say 2 millimeters from the edge and select OK. And then I'm going to just double check, clicking on the top. That's gone all the way through. Well, it kind of has. I'm going to click the bottom. I'm going to delete it. See if I can. There you go. So it does create a shell, but it hadn't gone all the way down. So all I did there was select a face, which was in the middle, and deleted it. So then when I click home, yes, I can see I've got the equivalent. Looks like it must have probably gone down to the middle when I did that. So I've now got, well, in fact, that isn't what I want, is it? No, it isn't, because that's not actually, that's what that's done is it's gone through the loft, hasn't it? Well, which is cool. It's created a lot of, what do we need? You can't create a shell in this example. Sort of made a useful design mistake here in that it's just creating a shell. It's adhering to the shell principle. So what I really do need is a hole here, don't I? So Control Z, that's right, Control Z, wind it back. What do I need? I need a hole. So I'll select top, make sure the face is selected. I will create another, let's do it as a sketch. Let's create a hole. Let's click once to latch it in the middle and pull it out. What do I want the hole to be? I want it to be 6 millimeters, which is adheres to pretty much what I want for the central PLA hub. Okay, that's cool. And finish the sketch. Now, what do I want to do with this this circle? I want to turn it into a hole. How am I going to do that? Well, let's go to extrude, because I want to extrude this hole or circle, and I want to extrude it. Let's see if I can go to like this, and so I'm in that home position. I want to extrude it all the way down to a little bit beneath the bottom, because I don't want it to cut all the way through, right? And you can see the operation is a cut, all right? You can choose a join, a cut, an intersect, or a new body, but this is a cut. Hit return. Aha! Now let's go and hit top. Oh yes, definitely all the way through. Home. Click on it or hover over it, and I can see yes, it's a 6 millimeter extruded circle effectively through the center of the barrel. Right, that's it. It's complete. It's to the dimension spec I want. I made a little mistake, which was probably a useful avenue in itself to show you the difference between a shell and a hole. There's lots. You can create a hole using the H, but sometimes it's just easy to create a sketch and extrude through this, from the sketch through the object. Of course, you can extrude upwards, extrude downwards. You just use the arrow or use the measurement to go and do it. So I now want to go and save it. Control S. We'll call it wheel Hoover 81 L. So that main project. Save it. And then we either can go and do a 3D print, converts it to a selected body to a mesh, and outputs it to an STL or a 3D print utility. Let's give that a go, actually. Normally I would say export, and I would choose either an object to pull it into Cura, or I go all the way to the bottom and choose STL. But I assume it'll do something similar to that, right? So we'll go there, 3D print, alrighty. So, all right, print utility custom. Mesh mixer, yeah, I think I'll leave it as custom. Output, custom, application, Cura. So I've set this already. I remember I did set this. You click on that folder, and then I think you point it to a 3D print utility. So It says Cura at the moment. So what I did, in fact, let's just double check. I have got it pointing to the right place. I want it to go to the exe file. So it'll be under, it's going to be under the C drive, right? It's going to be under program files, probably program files rather than 86. It's probably going to be under Ultimaker, because that's who makes Cura. Here we are, but I need the latest version, and I need to select Cura. Right, so I pointed it to the latest version. I select the objects. Let's have a look. It's thinking. Oh ho, whoopee doo. And you can see it. That's the first time I've used this actually. Normally I just export it. That's pretty cool. So now it creates all the splines. Let's do a freeorbit. Ooh, there you go. So you can see all the splines it's had to generate in order to print this puppy. Interesting. Now the layers it creates inside of there, look. Wow. Yeah, well, anyway, that is now, and effectively, we go back home again. It's now in the format, press escape, and we'll say, oh, there's a number of triangles then that it's created. And yeah, refinement is high. I suppose you can set different refinement levels. And we'll say, okay. Let's see what happens next. I presume it's going to fire up Fusion 3.6, sorry, fire up Cura 4.6. Let's see what happens next. Yep, there you go. Cool. While that's loading, I'm going to fire up my printer remotely because I've got a little application that switches on the plug. You can pick up these Wi-Fi based power sockets for about 19 quid or less. A smart socket effectively. Quite handy if you want to do remote printing and you want to switch off your printer. So the printer is currently powering up, so my Raspberry Pi with Octoprint is coming up as well. So while that's cooking, we'll just have to attempt to reconnect, and then once Raspberry Pi is up and Octoprint is loaded, I'll just make sure it's good to go. Get rid of that. Just wait for Cura to load. Cura is a bit slow to load, but it's good. I must admit, the more I use Cura on a daily basis, the more I really admire the work that's been put into this by all the developers. So Ultimaker is a separate company. What do they make? 3D printers and various other bits and bobs. Cura is their open source slicer. So it takes the STL file or object or whatever's been sent to Cura, and it slices that into layers and turns that into machine code. That's pretty cool. There you go. We're good to go. You can also interface it, and I've shown this before. So the printer's up, the camera's up, look. So there's the wham bam waiting. So we can go and preheat that, preheat the bed, because always good to start heating the bed up first. So it's nice and warm. And then this plastic PET, in fact, I think wham bam uses slightly different plastic, starts to go a bit gooey, and this turns glossy. And it basically forms the grippiness. So you don't need any of the usual lacquers and sprays that people use. It's quite a useful plate that I use both the Ender build plate, because this is a Creality Ender Pro 3, and I use the Wham Bam system because I had the Wham Bam for an Anycubic. I converted it, but I got rid of the Anycubic. I've gone for this this Ender, which is a really cracking little 3D printer. And I've used the existing magnetic bed, but I've dropped the Wham Bam build plate on it. So we're going to print this out in TPU. And in order to do that, I'm going to have to go and swap the readout to TPU, because I think I've got a PLA in there at the moment. In terms of the Let's just zoom in here then. In terms of how do I want this object to render, I want this object to render 3 wall line count probably. Top and bottom layers, yes, I'm going to need top layer of probably 5, a bottom layer of 5. As TPU is quite rubbery, I want these top and bottom layers to be quite dense, so I need to, I'll probably have no infill at this stage, just so I can have a look at what it looks like with or without infill. I want a 205 for the temperature on the head. Build plate can be a little bit cooler, 50. And I want a print speed of only 40. Nice and slow. TPU is very gentle material. I want a brim. Yeah, we'll go for a brim of 3 millimeters. I'm going to see if there's another setting here called bottom layer speed, because I would like the bottom layers. Is there a bottom layer speed? I know there's a first layer. I want it to be quite, remove empty layers. I think it does have it built in anyway, where it starts out the first layers slow, because what it's doing is it's building up the if you like, the sticky bit, the prime bit, if you like, or the, what do they call it, the bit where it squishes the material into the build plate, and I think they call it the squish, but it's the bit that sometimes with TPU it gets a little bit non-meshy, it's just not smooth. So you have to make sure that the bottom layer starts out a bit slower than the top layer. I think that is okay. Anyway, for the time being, we'll just accept that it is there. I'll have to go and fiddle around with the settings that live behind here to see if there's other settings I can look at for the initial layers that it builds out, but I'm pretty certain it does start out slower. Okay, so that's okay. I'm fairly happy that will print. Let's slice it. And let's preview it to see what it looks like on the inside. Right, let's scroll down. Yeah, it looks pretty good, although I think what I'm more inclined to do is, well, I got 2 choices. I can make this solid, couldn't I? How am I going to make this solid? I could either use infill, but probably the better way is just to increase the wall count to, let's try 4, slice it. You could use infill, but if I use wall count, see how it's concentric? Yeah? So let's bump that up 1 more. And the nice thing about having a concentric build up rather than having zigzag or honeycomb or whatever the infill is, the print head is simply moving around in circles, right? So that is more efficient than, it doing a circle, then zizzes it, whatever it does with its infill. I was thinking about this the other day. It's just more logical to have concentric in there. So by playing around with the wall settings, now, yes, you can have an infill that has concentric. Excuse me. Let's go for 6. But this, using wool, you get proper concentric. Because infill is not the same as having a wall thickness. The two are mutually exclusive. Alright, well, there's a bit of a gap there, look. Yeah, so if I do want this to be truly solid, and again, I could play with the top and bottom layers as well. You could just play with the top and bottom thickness. So you could say bottom layers of 15, top layers of 15. Let's have a look, see if that fills it in completely. I'm after a solid wheel basically, so I'm messing around with wall settings and yeah, a little bit there. Look, see where it's it's filled in quite a lot. All right, well, horses for courses. Let's go for a little bit of infill of 10%, and let's go for concentric. So pattern of infill material of the print. The line and zigzag will swap direction and alternate layers. What else have we got? Can we go for lines? Let's see how that works. I'm trying to get this so the head is moving around in circles all the time, rather than trying to do... Yeah, let's go for that. In fact, if you really want to see inside, just let's go right inside. Yeah, there's the lines with the infill there. Did you see it? Okay, let's change that to... Let's change that to concentric. Slice it. I just wanted to do circular lines effectively. I reckon. Let's do gyroid. What I really wanted to do is circular lines. I'd not found a way to do this yet. I thought it was just lines, but we can see, look, this is the infill in between the walls. Anyway, look, I rab it on, but it's good enough, right? But it would be really nice if I could just have this circular. Right, so it's doing circle, 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 circle until it's thick. Anyway, if you do know a way, drop me a comment. All right, I'll probably figure it out, but let's just try one more. Quartic cube, octet, cubic subdivision, lines, grid, triangles. Cross 3D, cubic subdivision. I need to experiment with these, but I'm not going to waste any more time on the recording. I just wanted to show you some ways of getting what you want, the way you want to see it, and the way you want to print it. Yeah, okay, so that is good to go. I just need to go and swap it out and print it out in TPU. All right, that's it for now. Hope you enjoyed the video. Have you got anything you want to say? Yeah, fire away in the comments. I hope you're safe and well, and I'm sure, like you, we're all looking forward to getting back to some form of normality. All right, good luck, guys. Catch you later.